Hello, today I will be talking about an example of a reaction catalyzed by DNA polymerase III. For the sake of time, I drew the DNA template strand, and I'm only going to be drawing one RNTP added by primase, which is going to be this first addition up here. So the A is going to be connected to a U. The way we know this is a ribose sugar is because there's a hydroxyl group on this second carbon right here. And I won't be able to fit the triphosphate version of an RNTP, but I will draw it as a monophosphate. So this just shows that it's connected to other RNTPs because there's about 10 to 12 that make up the RNA primer, and this is going to be synthesized in the 5 to 3 direction, and you can see the templates running through 3 to 5. So there's this monophosphate, but from the leaving group from this is this diphosphate up here. And water is going to come in and attack a P, and this is eventually going to create two of these, so times 2. And the reason the triphosphate is necessary in these reactions is because the leaving group of the diphosphate and then the separation of this into monophosphates, which is also called hydrolysis of the pyrophosphate, makes this a spontaneous reaction and the free energy change negative. So it's what makes this whole reaction possible. And from this hydroxyl group, there's going to be a phosphodiester bond that connects it to the DNTP. So let me draw a DNTP molecule, which the DNA polymerase III is going to be bringing in. So the C is going to be connected to a G. So this only has an H, not a hydroxyl group at this second prime carbon. And again, I'm just going to be drawing this as a monophosphate for the sake of space. And with these two hydroxyl groups right here is going to be the formation of a phosphodiester bond. So on this 3' carbon of the RNTP, there is a lone pair on this oxygen, which is going to come in and attack this phosphorus. And this would normally be a triphosphate, and as a result, this phosphate needs to break one of its bonds with its O's. So that bond breakage is what sends the diphosphate away. So we're going to erase these hydroxyl groups right here. And there's a phosphodiester bond. And the same thing's going to happen here when another DNTP gets brought in. So the A connects to the T. And we're going to leave this hydroxyl group on the 3rd carbon because nothing's going to be bonded to it yet. It's open for bonding. Then I'll just draw this as a triphosphate, so what it would normally look like. I also just want to add that the hydrogen bonds that are between the bases form because the bases are nonpolar and have slightly positive or negative charges on the groups that are attached to it. So these partial charges attract each other and create the hydrogen bonds. And depending on how many partial charges there are, that creates how many bonds, hydrogen bonds there's going to be. So the G and C have 3, and A and U, or like A and T, have 2. And finally, here is another phosphodiester bond forming, and that's an example of a reaction catalyzed by DNA polymerase 3. Thank you.